motor running at 800 rpm is controlled by single phase full converter. The motor rated armature current is 25 amp, armature resistance is 0.5 ohm, the AC supply voltage is 230 volt, motor voltage constant is 0.172 voltage per rpm. To make the current continuous and ripple free, assume that sufficient inductance is present in the armature circuit. Okay, so you have two parts in this question. First part is that for motoring action, determine motor torque, speed of motor, supply power factor for alpha is equal to 60 degrees, and rated and for rated motor armature current. Now second part is that for a regenerative action, motor back EMF polarity is reversed by reversing field excitation. Find firing angle to keep motor current as value and find power fed back to supply. Okay, this is the question. Okay, so it's a lengthy question. Okay, so we will start solving this problem by what he is asking. So first he has two parts of the question, so one by one we will see. First part is that is the first part. For motoring action, determine motor torque, speed of motor, supply power factor. Okay, so see the solution. So see for motoring action, so it's a motoring action. So for motoring action, I hope you might have remembered this thing, the motoring action and regenerative action. Okay, so I don't want to explain more about them. So first motoring action. So what he's asking what is the motor torque? What is the torque? He's asking torque. Okay. Second, he's asking speed of the motor. How much? Third one, he's asking supply power factor. The questions he's asking. First of all, what is this? What is this problem? Is that it is a single phase fully controlled. So it's a single phase fully controlled fed. So this is RA, this is LA, and the EMF induced here is EB, and the current here flowing is IA, armature current IA, and the voltage to the entire motor terminals is VA, and the supply voltage is VS. So this is the circuit he has given. He said now he's asking you to find out what is the torque, what is the speed, what is the power factor. One by one we'll go here. Okay. So now what are the equations to find the torque? What are the equations? Okay, first we will know about these equations. Okay, so torque, if you remember, torque can be written as EB into IA by omega. Okay, so what is EB here? EB is, if you recall, pi Zn by 60 into P by A. Okay, that is equal to pi Zp by 60 into A into N, that is EB. Now you see few things you must understand here. These are the equations. Now coming to the data what he has given, then this is the thing. So to solve this, we will go with the data what he has given. Now you see here data what he has given. He said a 210 volt. Okay, 1 HP separate excited DC motor running at 800 RPM is controlled by single phase full converter. Okay. The motor rated armature current is 25 ampere. Armature resistance is RA is equal to 0.5. The supply voltage is this. Okay. So he's asking to find out what is the, so yeah, supply voltage is 230 volts. Motor voltage constant is 0.172 volt per RPM. Okay. This we will take now. The motor constant, voltage constant. Okay. Voltage constant. He said 0.172 volt per RPM. You must understand that. See, this voltage constant you will always get from the back EMF equation, whereas the torque constant you will get always from the torque equation. So from the voltage equation, as the voltage constant is 0.172 volt per RPM. See the unit here. Unit is volt per RPM. Volt per RPM. So now if you see this equation, what is this constant? This is a constant because phi is constant, z is constant, p is constant. Because let me go. Did he mention anything regarding the field? He did not mention anything regarding the field here. So, and that is, it's a separate excited motor. And so he did not mention anything regarding the field circuit. So we will take it's a field totally coming from a separate source, and it is a constant. So phi is constant, z is constant, p is constant, 60. Yeah, everything is constant except n is there. So then what is this constant? If I take this as a constant, so some constant k I will take. So if I take this as constant, then this constant is EB by N. What is EB? EB is voltage. What is N? N is in RPM. So volt per RPM. So the unit of this is volt per RPM. Now the voltage constant which he has given is also volt per RPM. It means K is equal to, he has given the problem as 0.172. That's it. So we got the value of K. Which K here? This K. And what is this K value? 5ZP by 60A. This is the K value. So this one is K. Okay. And this value has given 0.172. Okay. Then we'll do one thing. Okay. So coming to this one, coming to the torque. Now torque is equal to EB. What is EB? We got here K into N. So K into N. Or we will do one thing. We'll just as it is first time. Okay. First time. So yeah, we'll put like that only. If it is necessary, we'll see this thing. So K into N into IA by omega. How can I write omega? I can write omega as 2 pi N by 60. So 60 will come here. Then what you will get here? N will get cancelled. So K into 60 IA by 2 pi. This is what you will get here. So T is equal to K into 60 IA by 2 pi. So K value we know. We don't know what is IA value. So IA value we will check in the problem. What he has given. See this now. The motor rated armature current is 25 ampere. Now you have to see the question first. For motoring action, determine motor torque, speed of the motor, supply power factor. For alpha is equal to 60 degrees. And for rated motor armature. So in the question itself, he said that the armature current is rated one. Now what is the rated armature current he has given in the problem is 25 ampere. So IA is equal to 25 ampere. So I will write here that IA is equal to 25. Then we'll substitute this here. So T is equal to K value 0.172 into 60 into IA is 25 divided by 2 into pi. So what is the answer you will get if I do this? So what is the value? 0.172 multiply with 60 multiply with 25 divided by 2 divided by pi. So 41.06. So this is the torque you got. So 41.06 Newton meter. This is the value of torque you got. What is the next question? Speed. You have to find out the speed. So how can I get the speed? Now we got one equation here. EB is equal to, so next question is you have to find the speed. So where can I find out speed? We have got a equation EB is equal to K into N. So this N we have to find out now. So what is the value of N from this now? The value of N is EB by K. K value you know, so you have to find out what is EB. What is EB? What is EB? If you recall, for a motor, for a motor, for a DC motor, what is, how can I find out EB? EB can be find out. Okay, so from this equation, which equation? VA minus IA RA. This is for the motor equation. Back EMF is equal to VA minus IA RA. Okay, that is equal. That is equal. So that is equal to, we'll simplify that. But before we simplify, what is VA here? VA. What is VA? We need to know what is VA. IA value we know that is 25 ampere because he said at rated armature current, so 25 ampere. And RA value he has given in the problem as 0.5. I think. Just let's go. Yeah, this is RA. RA he has given. So IA he has given, RA he has given. So I will write here this side. Okay, I will write this side here. RA is equal to 0.5 ohm. IA is equal to 25 ampere. So what we don't know what is VA. So we will find out VA. How to find out VA is that, what is VA in this problem? VA is nothing but output of the full converter. So if the output of so what is the equation for the output of full converter? Last class, if you recall, we got two equations for the output of full converter. One is for discontinuous conduction mode, the other is for continuous conduction mode. Now we will see what is this mode. Is it a continuous conduction mode or discontinuous conduction mode? So if you see here, you will find out to make the current continuous and ripple free. So the current is continuous and ripple free. I told you already that. So now you see here, what you need to see here is that he said that to make the current continuous and ripple free. So what is meant by continuous and ripple free? Continuous ripple free is nothing but continuous and constant. See, I will write here continuous and ripple free. So first we will take this word continuous in the sense we know already. Ripple free in the sense there is no ripple. Ripple free in the sense it is free of ripple. So ripple in the sense, for example, I have a waveform like this. This waveform has a ripple. What is meant by ripple free? Ripple free in the sense just a straight line. Now the straight line do not have any ripple. So ripple free in the sense, always remember a constant value. Constant value is nothing but, whereas this waveform is a ripple. It has ripple. It has ripple. Here no ripple. So ripple in the sense the value changes from one value to the other value. It comes decrease, increase, decrease, increase. This you call, it has ripple. Whereas no increment, no decrement, or it's a constant. You can call it as ripple free. Okay, you can call it as ripple free. Okay, so that data he has given. So it means indirectly he said it is a continuous conduction mode. So for a continuous conduction mode, what is the expression for VA? Is 2Vm by pi into cos alpha. So 2 Vm. Vm is the maximum value of the supply voltage. The RMS value of supply voltage he said in the problem as 230 volts. It is 230 volts. So if it is 230 volts, what is its RMS value? RMS value will be 230 into root 2 divided by pi into cos. Now, what is the firing angle he has given in the problem? In the problem, he has given firing angle as alpha is equal to 60 degrees. So you put 60. 60. Okay, so then what is the answer you will get to? I'll just see in the calculator. So we got an answer that has 103.53. Or we will put 103.52 only. So 103.52. So this is VA value. Now we'll substitute the
536
value.
వచ్చి
536 వచ్చిందా?
అవును సార్.
Okay, no problem. Okay, so it's in this calculator. Okay, I think I haven't taken the root 2 properly. No problem. It really does not matter. So 103.52. So we'll put here in the previous equation. So 103.52 minus 25 into 0.5. Okay, what is the answer you will get if I do this? If I do this, what is the answer you will get here? So 91.02 you will get. So the back EMF is 91.02 volts. Okay, this you got. Now he's asking, now we'll bring this equation here. EB is equal to Kn. So 91.02 is equal K value is equal to 0.172 into N. So from this, what is the value of N is, what is the value of N? The value of N is 0.172. So 529.1. So we'll take here a 529.1 RPM. So this is the second question. So we got the second question also. Now we'll go to the third question. What is third question? Supply power factor. He said here supply power factor. See, last class I told you this thing that supply power factor in the sense you have to find out the power factor here. What is the power factor here at the supply? At the input supply, he is asking the power factor. So regarding the power factor, last class I told you that you cannot use this equation cos alpha or cos theta as power factor because that is valid only for the sinusoidal excitations or sinusoidal variables. Whereas whenever you have a power electronic converter in any power system case, then this power electronic converter, because of this power electronic converter, the current waveform or the voltage waveform is a non-sinusoidal one. If it is a non-sinusoidal waveform, then you cannot use this equation cos theta directly. Rather, you have to follow some other procedure. What is that procedure that I told you last class is to find out the power factor is power factor is power factor is equal to real power divided by apparent power. This I told you already that the real power and the apparent power. Okay, so what is the real power here? First of all, if you see this single phase full converter, where do you find out the real power? Real power in the sense the power which is being consumed by the motor. So simple thing that the motor voltage is here, the motor current is here. Motor voltage is here, motor current is. So you multiply the voltage and current because this is a DC motor. So DC voltage, DC current is. So whatever you got the power here, there is a DC power. That is the output power of your the converter, or it is the output real power of the converter. So you can take this as a or how you are getting this real power? You are getting the real power from the supply, and there are no losses here. So when there are no losses in the full converter, in the full converter there are no losses. It means whatever the input real power here you will have the same real power at the output side. See here, very simple that this converter is there. The converter input power will go through the thyristors and it will go to the motor. So the output of the full converter and the input of the full converter, there is a small difference. That difference is the power loss in the thyristors. Now he did not mention anything regarding the power loss in the thyristor, so we will take this thyristor loss as 0. So when the thyristor loss as 0, then the input real power is same as the output real power. So what is the output real power? Output voltage multiplied with the output current. So the real power here is nothing but output of your converter. So output of your converter is a DC. So output voltage is how much? VA. Output current is IA. This you will find out. Okay, divided by apparent power. So what is the apparent power here? Apparent power in the sense supply VRMS into IRMS at the supply side. That is VS into IS. Both are RMS values. VS into IS. Okay. So if you do this division, then you will get the power factor. So now we will go how to do this now. One by one, we will find out in this equation, power factor equation. First VA. What is VA? VA he has given in VA we got in the problem. How we got 103.52. So 103.52. IA he said it is a rated current, so it is 25 ampere in the problem he has given. VS RMS value of the supply voltage is 230 volt, that also he has given. Now RMS value of the supply current, this we don't know. So we have to find out this one. So to find out this, we need to draw the waveform. We need to draw the current waveform. Which current waveform? Supply current waveform. That I will do now here. Yeah, this is a circuit diagram. So this is circuit diagram. So this here is IS. We have to draw the waveform here. Okay. So if you can draw the waveform of IS, if you can draw the waveform of IS, so then for that waveform we will find out the RMS value. Then we will get the answer. Then we need to draw the waveform once again. Okay. Okay. So why? This is supply voltage Vs. Okay. So now we will draw. Now I am going to draw the current waveform. Which current waveform is IA? I'm going to draw IA current waveform. I will tell you why I'm drawing the IA current waveform here. What is the IA current waveform here? Please see. The IA value, let me go to the question here. What he said now, you see this line. To make this current, to make the current continuous and ripple free. So it means the motor armature current is continuous and ripple free. That's very important. So the current here is continuous ripple free in the sense it's just a straight line. Just now I told you this thing. Continuous and ripple free is nothing but a constant value. And this constant value is how much? IA value. IA is the armature current. Now in the problem, we are solving the first problem itself. In the problem, he said rated motor armature current. So what is its rated motor armature current value? It is 25 ampere. So this height is 25 ampere. Okay. And then okay, now we don't want the IA value. Actually, what we want is that we want, okay, so this is the axis. Okay, we want the waveform for IS. We are interested to know the IF value, IS value. Okay, so now before we go further, so now why we are drawing this this current waveform is that we want to know the RMS value of IS. So please see this now. So where is alpha? Alpha is somewhere here. This is alpha. This is pi plus alpha. Okay. Alpha value. pi plus alpha. Is pi plus alpha. So see, if you recall, it's a continuous conduction. So if you recall very well that in the continuous conduction, you have in the continuous conduction, what you will do is that, so thyristor 1, thyristor 2, thyristor 3, thyristor 4. First, thyristors 1 and 3 will be on for the positive half cycle. That is at alpha, you trigger thyristors 1 and 3. So when you trigger thyristors 1 and 3, what is the closed path? You will find out is that the closed path is through 1 and 3, through 1 and 3. Okay, it will go like this, the black color, through 1 and 3. So to the motor. So it flows like this. It flows like this. So supply voltage 1, motor, and 3, and supply voltage. So this is the closed path. So in this closed path, IA, here is IA. Here is IA. If in this closed path, if this is IA, what is the value of IS? Just see here now. This is IS here. IS is the current here. IS is the current here. So if you take the closed path carefully, if you follow through the closed path, supply voltage and here is IS, that IS will flow through the thyristor 1, then that IS will go through the motor, then once again 3, and then supply voltage. So IS is flowing through the motor. So IS direction I am taking like this from left side to right side. So IS is flowing in the same direction of IA, or we can consider this thing as that between alpha to pi plus alpha. Why pi plus alpha? Because we have seen last class itself that from alpha to pi plus alpha, 1 and 3 will conduct. So when 1 and 3 are conducting, then I will say this thing that IS is equal to IA. Just check yourself. Just apply KCL, then you will understand this. 1 and 3 are conducting, supply voltage, thyristor, and the motor. So what is the current in the motor? That is IA. And what is the direction of IS? IS direction is same as the IA direction. Both are from left side to right side. So IS is equal to IA from alpha to pi plus alpha. Then we will draw the waveform of IS from alpha to pi plus alpha. What is its value we got just now? We got its value as IA. So we'll write here it is IA. This height is IA. From alpha to pi plus alpha. We got. Okay. And then what's next? What is the situation from the next one? That is from pi plus alpha less than or equal to omega t less than or equal to 2 pi plus alpha. So the next to 180 degrees, what is the value? Next to 180 degrees, which thyristors will conduct? If you observe carefully, then you will understand yourself is that. So next one, now we trigger 2 and 4. So 2 and 4 are triggering. Then how the current flows? The current will flow like this time. How it flows? It flows like this. Because now from pi plus alpha, the voltage is negative. So when the voltage is negative in the sense, negative half cycle. So negative half cycle in the sense, the current will flow like this. Earlier it is from left side to right side. Now it is right side to left side. Okay, so like this. Whereas okay, so now you see here, this time the current flows like this. Earlier it is flowing, top one is positive, bottom is negative. Now bottom is negative, top is positive, so it flows like this, then it goes like this, then it enters into 2, then it goes through the motor, and then it goes like this, then after that it comes, okay, and flows like this. Now if you observe carefully here in this duration, the IS direction and IA direction both are in opposite. Just see this now yourself, because you see the arrow of the blue color here, blue color arrow here, black color arrow, both are in opposite direction. So you will find out this thing that IS value is equal to minus IA. This you will find out. That is from pi plus alpha to 2 pi plus alpha. So where is 2 pi plus alpha here? 2 pi plus alpha is here. But one thing what you must understand is that it is not IA, but it is minus IA. So what is IA here? IA is still constant. So minus IA in the sense it's negative. It is negative. So it is negative. So we join this. Okay, then so this process will be repeated. So you got a pulse here. You see here, you got a rectangular pulse here. So this rectangular pulse height is how much here? IA only. Height is IA. Height is IA. So it's a so IS waveform. Here you got a rectangular waveform. IS you got a rectangular waveform. What is the time period? It is alpha to pi plus alpha, then pi plus alpha, 2 pi plus alpha. So what is the time period here? 2 pi is the time period. 2 pi is the time period. So how do you find out the RMS value of a rectangular pulse? It's a rectangle. So the answer here you got IS. You'll know that IS is rectangular pulse. So with time period T is equal to 2 pi radians. So what is the RMS value of a rectangular pulse? So I will write directly because you can find out yourself. The RMS value, IS RMS value is equal to peak value of pulse. See this I'm directly writing, you can go through yourself. Okay, this is a pulse here. You find out yourself the RMS value of this pulse from the for this time period 2 pi. Then you will know yourself the RMS value is exactly same as the peak of this pulse. What is the peak of this pulse? That is nothing but IA. So we'll do one thing here. We'll go to this power factor equation. So VA into IA by VS into, now you got IS value is also IA because the peak value here pulse is IA. So IA will get cancelled. So it is equal VA by VS. VA by A. What is VA here? 103.5 divided by, what is VS? 230 volts. Then what is the answer you will get here if I do this thing? Uh, so 0.45 lagging power factor. That's it. So this is the supply power factor. We got the first question already. So now we'll go to the second question. What is the second question? Second question is that for a regenerative action, motor back EMF polarity is reversed by reversing field excitation. Okay, we'll do one thing. We'll just copy this. We'll solve this side. Yeah, for regenerative action, motor back EMF polarity is reversed by reversing field excitation. So it's interesting that now we are entering into regenerative action. I hope you know what is the regenerative action. In the regenerative action, motor will fed the power back to the supply. That's called regenerative. So it means generally motor will take the supply in the motoring action, whereas in the regenerative action, the DC machine or DC motor will give the power back to supply. That is called regenerative action. Okay. So here he said that, what he said is that in regenerative action, motor back EMF polarity is reversed by reversing field excitation. Now you see here EB is equal to, I hope you remember, 5ZN by 60 into P by A. This is done. So its polarity is reversed by reversing the field excitation. In the sense, you have the field winding is there, so reverse the polarity of the field winding supply. So when you reverse the polarity of the field winding supply, then phi becomes negative. Your flux phi becomes negative. If the flux phi becomes negative, then EB also becomes negative. So this is how he said, for regenerative action, motor back EMF polarity is reversed by reversing field excitation. So now EB is negative this time. This is first thing. Okay. Now what he is asking, find the firing angle to keep motor constant as valid value and power fed back to the supply. So in the regenerative action, okay, so regeneration in the sense, now remember the motor is acting as a generator. That's called regenerative action. Okay. So this is your motor. So now what is meant by regenerative action is that, see here, always remember regenerative action is this is now the motor is working as uh, a generator. So it means motor generally takes power. Now this time motor will give the power back. So if you think the power is going back in the sense, generally this polarity you might know, when power is positive, whenever the power is positive, it acts as a load. This you might have studied in the circuits also. Whenever the power of any element is negative, whenever the power of any element is negative, it acts as a source. So generally someone said that 10-watt power, in the sense what, that positive power is a uh, okay. So when you have the power is positive, when you have the power is positive, it means that element, in any element, if the power is positive, then it is called, that element is, you can call it as a load which takes power. In any element, if the power is negative, then you can consider that element as a source. That is the meaning of this. So here, as it is a generating action in the sense it is acting as a source. Generating action in the sense it is acting as a generator. Generator is nothing but the source. So source of power. So it is acting as a generator in the sense its power should be negative. That's what I'm saying. So if the power is negative, how it is power is negative? When the power is negative, P is equal to voltage into current. Voltage into current. This is the power equation. Voltage into current. So the power is negative, he said, in the sense either EB is negative or IA is negative, not both, because if both are negative, 1 second the power becomes positive. So here either EB is positive, either EB is negative or IA is negative. What he said now in the problem, EB is negative. He himself has given that EB is negative. He's interchanging the field winding. Here's the field winding. This is the field winding. So the plus minus polarity is there. He is interchanging this. So when he interchange the plus and minus polarity, obviously flux becomes negative. So EB is negative. So when EB is negative, what is its value now? EB is equal, same thing. This time minus K into N. Minus K into N. So already we find out EB value in the first problem. What is the EB value we got in the first problem now? So now EB value in the first problem is how much you got? Yeah, 91.02. This is EB value. Now he said that he is reversing the field winding excitation. He is reversing the polarity of the field. So immediately when he interchange the polarity of the field winding excitation, EB will become negative immediately. So when it becomes negative immediately, previously it was EB is equal to 91.02. Now when you interchange this and EB becomes immediately negative. When EB is negative, IA is positive. Otherwise, the product cannot be negative. So this is negative, whereas this should be positive. So it means the IA will be in the same direction, whereas EB will become negative. So how much it is? Minus. Just why I take the as it is 91.02 is that this is the value you got in the motoring action, and when it is acting as a motor, suddenly you are reversing the field winding excitation terminals. When you exchange the field excitation terminals, then immediately EB becomes same value but it is negative. EB becomes same value but it is negative. So same value in the sense 91.02, its negative is minus 91.02. Okay, then what he's asking now in the question? What is the firing angle he's asking in the question? So how to find out the firing angle here? Only one equation you have to find out the firing angle. What is that equation? Is that VA is equal to 2Vm by pi into cos alpha. So here only you have the firing angle. Then what is your job is now find out VA. Vm value 230, 230 into root 2, that you know. To find out alpha, you need to know what is VA. How to find out VA now? See here, very simple thing. VA is equal to now, VA, this equation, you know, VA is equal to EB plus IA RA. So here EB is now it is negative, so minus 91.02, and IA remains in the same direction. I said it is positive only. So IA value in the problem has generated value 25 into 0.5. That is equal to, if you solve this, then minus 91.02. So minus 78.52. That is minus 78.52. This is the armature voltage. This is the armature voltage. This is armature voltage VA you got. So if you got VA here, substitute here now. 78.52 is equal to 230 into root 2 into 2 by pi into cos alpha. So we have to find out what is cos alpha. So now you see here, how to find out cos alpha is that into pi divided by 230 divided by 2, 1.414. So minus 0.379. So if it is minus 0.379, so cos function cos alpha is, so we'll do, now we have inverse here. Yeah, we got directly using the calculator. That is 112.28. So the alpha value, the firing angle value is 112 point much 112.29 or 28 only. So this is the answer. This is the answer. So we got the firing angle. Now what is the next question he's asking in that only? He's asking power fed back to supply. So how much power is being fed back to supply? Now I said that this is acting as a generator. So if it is acting as a generator, then this generator has to give the supply back to your source. How to find out how much supply it is going back to source is that very simple answer, that first we will find out how much power is generated here. How much power is generated here? How much is generated here? So that value we will find out. So once we find out that value, then so how to find out the power from this generator? So EB into IA is the power generated. So that power is now going back in this direction to the supply. So first we'll find out the power here. Then that power, from that power we'll subtract some losses if there are any losses here. Then the power generated minus losses will be the power going to the converter, or it is going indirectly to the supply. So first power we will find out, input power. Input power is equal to EB into IA, because here is the input power now. EB value is how much here? 91.02. So into, now we will take only the magnitude. Why we will take only the magnitude is that already we are saying it is acting as generator, and it is giving until we are saying it is a input power. So as we ourselves has told that it is input power, so we generally take it as positive only. So 2275.5. So 2275.5. So this is the input power. So from this input power we will find out what is the, okay, what is the losses. How do you find out the losses here? The losses we'll find out is that, so there is a loss in the armature resistance. So IA square RA. This is the only loss, because he did not mention anything regarding the losses in the thyristor. So IA square, so 25 square into RA. RA value is 0.5. So how much you will get is that? 312.5. So 312.5 is the power loss. Now what is output power then? Output power are, so remaining power, input power minus losses is the remaining power. How much? 2275.5 minus 312.5 watt. So 1963 watt. So that is the power that is going back, 1963 watt. This is the power that is going back to the source. So this is the answer for this. We can find out this answer in other way also. How to find out the other way is that, see, the input power is VA into IA. VA into IA is the output power. Why am, see, it is, see, now the motor is acting as a generator. So here is this generating, then there are some losses, then remaining is this power. So that power is there. So VA IA, VA value how much we got here just now? 78.52, okay, into 25. So this way also you can find out, we must get more or less same answer. 8.52 into, yeah, we got the same answer. 1963 watts. So this is how you find out the power that is going back to the supply. Okay, this is the answer for the second question.